Guys, this is section 6.4. If you have a calculator on your desk, could you please look at your calculator? And do you guys see where it says sine, cosine, and tangent on your trig functions? Either above it or on the same button, something like that. Do you guys see where it says sine -1, cosine -1? Okay, those are your inverse trig functions. We're going to talk about that in a second. Inverse just means what? Opposite, all right? You guys are familiar, you should be, if you're told that the sine of a theta or an angle is something, sine, the ratio is y over r. Cosine is x over r. Tangent is x over y. Everybody remember that? Yes? Hopefully. We need to get that memorized, please. We're talking here, look, this is the notation for inverses. You see that sine -1, cosine -1? And then we're going to talk a little bit about domain and ranges. We'll talk more about this later. I'm not worried about this right this second. But the way that we say inverse sine or sine -1, you guys will also hear that be called, right down here. Look, it says arc sine, arc cosine, and arc tangent. That's the same thing as sine -1, cosine -1, tangent -1, or inverse. It's called arc sine. So if it says to you, like, using arc sine, that's not something random on the calculator. It's the second sign to where the little -1 comes up. And we'll practice it. But if you're asked to be given the exact value on the unit circle, guys, this is pretty easy. You don't have to think really far outside of the box when you have exact value. If I ask you what the sine is, and it's on the unit circle, if I ask you what the sine is, what is that value that they're talking about? X, Y, X over Y. What is sine? If you're given an ordered pair, what is sine? Y. Sine is the Y value. The Y value. So if I look here, and this is positive, correct? You see any negatives or anything on it? It's positive. So let's look in the first quadrant where everything's positive. Where is the Y value? Root 3 over 2.
Pi over 3.
Pi over 3 and? Pi over 3 and?
2 pi over...
No. Pi over 3 and?
60
degrees. That would be your answer here. If they ask you for both, or if they ask you with the exact value, you would say pi over 3, 60 degrees. Same thing. What is cosine? X value. Now, X value. So I'm looking on the unit circle in the top quadrant here, where the X value is -1/2. Where is the X value in the top quadrant? -1/2. 2 pi over 3 and also 120. Good. 2 pi over 3 and 120 degrees. Now, I'll tell you why I'm looking in certain places in a second. The last one says tangent is 1. What does that mean? Okay, +1. Good. What does tangent mean? Y over X. So think about this. On the unit circle, what ordered pair would give me 1? Okay, we're back. What ordered pair, guys? What is the only ordered pair? Ordered pair. I agree with you, but ordered pair. What's the only one that could give us, excuse me, a +1?
0, right?
No. Square root of 2 over 2 and? Square root of 2 over 2, because anything divided by itself is 1. So in the first quadrant, up on the top here, and I'll tell you why I'm looking there. Where would I get 1 when I put the X and the Y over each other, or the Y over the X?
45 degrees.
45 degrees and?
Pi over
4. Okay, now, 45 degrees, pi over 4. Now, some of you are like, well, how come you're looking here and there? When you are talking about sine and tangent, and we're talking about inverses, the only places you're allowed to look are on the right-hand side of your unit circle.
Wait, for sine and tangent?
For sine and tangent. For cosine, the only places you're allowed to look are on the top half. Whoops. And that's how you can tell, because there's always going to be 2 places that will give you either the positive answer or the negative answer. So you just have to see what you're looking at.
Wait, so why is sine and tangent the same but cosine is different?
That's just the way that it is. But on a question like that, I will give you the unit circle. So you just have to know where you have to look. Are you going to look at the right-hand side or the top? That makes sense? You guys just got to remember that. Okay, now you guys are going to want a bunch of these questions. I'm not going to give you a bunch, but you're going to want them. All right, you're going to answer this question. When it says approximate, do you see the word approximate? You're going to give your answer in both radians and degrees. But guys, this is where you have to start paying attention to your calculator. You're going to have to switch back and forth. Everybody with a calculator. I want you in your calculator right now to hit sine -1. So whatever your calculator has to do you hit second sine? The little -1 should come up.
Yeah.
And then put 0.71. Enter.
What do you want us to round to?
45.
No, give me 2 decimal places.
2, 3.
What do you guys get? 45.23 degrees. Make sure you write degrees. Just have to go. Thank you. Degrees. Okay, now go to your calculators and go to radian mode. If you don't know how to do that, ask me, look around, see what you do, but go to radian mode. Okay, now do the exact same thing. Hit second sine and then put 0.71. Enter. And what do you guys get? 0.789, so 0.79 radians. Guys, do you see a huge difference in those two numbers? Yes. Do you see why it is so important that your calculator is in the correct mode? It's not that if you're in degrees and radians, it's just a point or two off. It's super, super, super important that you're in the right mode. So if I go over here and I say, okay, I'm going to do cosine, and we're going to do it in degrees and in radians.
Are we doing degrees first or radians?
Let's do degrees first. Everybody, hold on one second. Everybody try it. If you have a calculator, I want you to hit second cosine, and then hit 2. What do you get?
Error.
Everybody do it. It says error, domain error. All right, we'll try it in radians, see what you get. Error again. Does that mean your calculator's wrong? Does that mean you did something wrong? No, that is a possible answer. You cannot, the inverse of cosine, positive 2, doesn't exist. And that's okay. You can get that as an answer. That is okay. Let's try with tangent. What happens when we do tangent? 63.43 degrees, okay? Agreed, guys? Nunez, you do it? Do tangent. We have tangent and we have degree. Tangent. We're going to do degrees and radians. But I got a number this time. So does it mean if the number is bigger than 1, you're always going to get an error message? No. Do you see how inverse cosine of 2 was an error, but inverse tangent of 2 was an actual value?
Can you please set back?
Do you guys see that? This is all calculator work. You have to make sure that you're putting this in your calculator correctly. You have to understand how to switch from degrees to radians, radians, degrees, that sort of thing. You guys with me?
Yeah.
Okay, let's keep, we're almost done. All right, find the angle in the right triangle below. Guys, this is right triangle trigonometry. Write this down, please. Everybody with me? To find an angle measure, use arc sine, arc cosine, and arc tangent. What does that mean when I say that? Arc sine, arc cosine, arc tangent.
Sine, tangent.
Sine -1, the inverse, right? Cosine -1. And tangent -1. When we were trying to find sides, we just used sine, cosine, and tangent. We were trying to find angles, an angle measure, use the inverse. And you have to be in degrees. So this is super, super, super easy. You guys can all handle this, no problem. Here is my theta. Everybody see theta that we're talking about. In regards to theta, what is 10 and what is 50? Opposite, adjacent, or hypotenuse?
10 to
10 is the what side?
the
Opposite, agreed. And what's 50? The hypotenuse. So what trig function, guys, in right triangle trigonometry uses opposite and hypotenuse? So you guys would say sine theta equals opposite, which is 10, over 50, which is your hypotenuse. Everybody with me?
Yes.
Okay, so if I simplify this, you guys agree with me, this is the sine of theta equals 1/5. Okay, that's great. Sine theta equals 1/5. I don't want to know what the sine of theta is. I want to know what the angle is. So guys, what is the opposite of sine?
Sine negative.
No, not reciprocal. I know what you're thinking. Reciprocal. But what's the opposite? What's the inverse of sine?
Arc sine.
Arc sine, this second sine, right? So if I do second sine on the left-hand side, they cancel out. So that means I have to do what on the right-hand side? Yep. So what you're doing in your calculator is this. Make sure you're in degrees. It's inverse operations. If you were adding, you would subtract. If you're multiplying, you would divide. Since we're taking the sine, you do the inverse, which is arc sine. So in your calculators, guys, hit second sine, and then in parentheses, put 1 divided by 5.
So yes.
Yeah.
And then it's
What are you guys getting? 11 point what? 54 degrees. Now, if you were in the wrong mode and you did it in radians, you would get an answer of 0.20135. Guys, does that make sense that an angle measure is 0.2? The measure of an angle that you're looking for is 0.2. Does that make sense? No. So if you get an answer like that and you're like, well, I don't know if I did that right, just check to make sure your calculator's in the right mode. But this is super easy. It's just one extra step from what we've done before. You have to hit second sine, second cosine, something like that. Let's do the next example. All right. A 40-foot ladder leans against a building. If the base of the ladder is 6 feet from the base of the building, what's the angle formed by the ladder in the building? Here's the triangle I'm looking at. Where is theta? Where'd they draw it, guys?
in the corner.
Do you see it up here in the corner? Okay, so that's the angle we're looking at. So what is 6 and what is 40?
The opposite and the hypotenuse.
6 is the opposite side and 40 is the hypotenuse, correct? So I would set this up as what? What trig function uses opposite and hypotenuse? So sine of theta, so not always going to be, no, is 6 over 40. You guys agree?
Yeah.
Now I'm trying to get theta all by itself. Can I simplify 6 and 40? Yeah, but don't worry about it. I want to get theta all by itself. So what's the opposite of sine of theta?
Arc sine.
Arc sine or second sine. So I'm going to hit sine negative 1 on this side, and I do the same thing on the other side, because what you do to one side of the equal sign, you do to the other. So theta equals, in your calculator, it should look just like this. What is theta in degrees?
8.63 degrees.
Okay, we got about 8.63 degrees. Okay, if accidentally you did it in radians, you would have gotten 0.15. Does that make sense that your angle measure would be 0.15? No. Less than 1 degree? No. Is this crazy hard? No. If you're looking for a side, you would just use regular sine, cosine, tangent. If you're looking for an angle measure, you have to use arc sine. So second sine, second cosine, that sort of thing. Yes, sir.
Can you go up to see what I was looking for?
To the previous problem?
Yeah.
Okay, hang on one sec. Okay, let's look at this last one. It says a lighthouse is located on an island that's 2 miles off a straight shoreline. Express the angle formed by the beam and the shoreline in terms of distance in this figure, okay? What are we looking at? Where is theta?
Theta is in the corner.
Theta is right here in the corner, right? So in regards to theta, they gave me information about two sides. What are those two sides?
Adjacent and opposite.
Adjacent and opposite, right? Hold on. So what trig function uses adjacent and opposite, or opposite and adjacent? Okay, what is it? Tangent, okay. So I have tangent of theta equals what over what? Okay, so it's what over what?
2 over D.
2 over d. So guys, let's do this in terms of distance. We're going to get theta all by itself. So what is the opposite of tangent of theta? Arctan, right? So if I take the arctangent of one side, then I have to take the arctangent of the other side, correct? So theta would equal the arctangent of 2 divided by the distance, whatever it is. That's how you would find that angle measure. If you want it in terms of d, we would solve for d. Here we're just trying to solve for theta. That's all it was, just rearranging. And they wanted you to see that to get the tangent to go away, the opposite would be arctangent.
Oh, okay, it's just, oh, okay.
That's all it was. I was just reading too far. Yeah, I was reading too far into it. That's it. They're not looking for an answer or a number or anything like that. Okay, guys, so the biggest takeaway from this, 6.4, the biggest takeaway is that when you're looking for a side length, all right, side length, you use sine, cosine, and tangent. When you are looking for an angle measure, what do you use? Arc sine, sine -1. Arc cosine, cosine -1, or arc tangent. Good, Hayden. All right, that's the biggest thing to take away from this. You guys have done right triangle trig a million times, just depending on what you're looking for. If you're looking for side lengths, you use sine, cosine, tangent. If you're looking for angle measures, you use the inverse. Make sense? Okay.